Hello everyone, welcome back to another episode of Solving LEETCODE Hard Question. Today's question is maximum frequency stack. The question is as follows. Design a stack-like data structure to push elements to the stack and pop the most frequent element from the stack. So implement a freq stack class as follows. Calling freq stack will construct an empty frequency stack. Calling push with the value will push the integer value onto the top of the stack. And calling pop will remove and return the most frequent element in the stack. If there's a tie for the most frequent element, the element closest to the stack's top is removed and returned. Let's look at the following example. If we push 5, 7, 5, 7, 4, 5 to the stack, and now we try to pop from the stack, what will happen? Well, since 5 is the most frequent element with a frequency of 3, popping it for the first time will return 5. Now, both 5 and 7 have a frequency of 2. So if we pop again, the closer one, 7, will be popped. Next, if we call pop again, since 5 is the most frequent element again, the result will be 5. Now, the remaining elements have the same frequency of 1. So if we call pop, then the popped element will be 4, which is the closest to the stack. How do we solve this question? Pause here if you'd like to think independently for a moment. We can first think about how this is different from a normal stack. Well, the key difference is that we always pop the most frequent element from the stack. So we probably want to know what each element's frequency is. We can do that by using a hash map to keep track of this frequency. In the example below, element 5 has appeared 3 times, element 7 has appeared twice, and the element 4 has appeared once. Now, what if 2 elements have the same frequency? The requirement is that we pop the element that is closer to the stack. So how do we know which one is inserted first? With the dictionary, we only know the element and its corresponding frequency. So we need to obtain the order information from something else, perhaps another data structure. Let's take a step back and look at the flat list. We can still make use of a normal stack somehow. With a flat list, it's very easy to implement stack. However, instead of popping from the top element, we only want to pop from the elements that have the top frequency. In this case, it's the element 5 and 7. So we can pop from this and obtain 7. In other words, if we can keep track of a 2D list where we store both the frequency information and if they have the same frequency, the order in which they're inserted, then we can pop the most frequent element, and if there are multiple elements, pop the one closer to the stack. In summary, we want to build a list of stacks where stack I is the stack of elements with frequency I. At push, we add the new element to stack I based on its frequency tracked by the frequency map. And at pop, we can remove from the top element from the top stack. Below, I wrote some code snippets. Every time we push an element, we need to update the frequency map and also insert to the corresponding stack. And every time we pop, we can just pop from the top stack, and also updating the frequency map correspondingly. Here is the complete code in Python. There are some extra steps needed to initialize the frequency map if it doesn't exist, or initialize a new stack. However, the core logic stays the same. The final time complexity is O of 1 for both push and pop, and the final space complexity is O of n for the frequency map and the 2D stack list. That's it for today. Thank you for listening and see you next time.